Okay, welcome back to Wednesday's review. Now tomorrow's video, what I'm going to do is it's not really going to be a review. We're going to talk about Le Chatelier's principle. That's the last part, and it is very, very easy, honestly. That I'll just put it into the tomorrow's video and everything and show you. And that's the last part of the assignment. Super simple. Okay, so today as a review, we're going to be figuring out equilibrium partial pressures. So the problem says for the equilibrium reaction below, K of P, so P representing pressure, is 7.0 at 400 Kelvin. If a cylinder is charged with BrCl at an initial pressure of 1 atmosphere and the system is allowed to reach equilibrium, what are the equilibrium partial pressures? Here's our reaction. So let's go ahead and let's set up our ice table. Alright, so looking up the problem, we have our equilibrium constant K of P, and we have initial pressure of BrCl. Now we don't have any information about bromine or chlorine, so its initial partial pressure is going to be 0. Okay, now if we go down to the change, since we have 0 on this side, our change is going to be positive, and it's going to be a plus x, because if we look, we only have coefficients of 1 in front of them. Now in front of BrCl, we have coefficient 2, so its change is going to be a minus 2x. Then down at equilibrium, combine initial and change, so x, 1 minus 2x. Now, even though we have information about looking at our forward reaction, our product instead of our reactants, we still set it up as products, BrCl over reactants. K of P is equal to the partial pressure of BrCl squared all over partial pressure of Br2 times concentrate, or partial pressure of Cl2. So let's put in all of our information that we have right here. K of P, well, and the problem is 7.0. And that's equal to 1 minus 2x, that's going to be squared over x times x. So let's kind of clean this up a little bit. 7.0, now we're going to need to FOIL that. So 1 minus 4x plus 4x squared all over x squared. Then we need to get the x squared out of the denominator, so we're going to multiply that by both sides. 7.0x squared is equal to 4x squared minus 4x plus 1. Then we need to get everything over to one side, and like I said, I like to keep my x squared positive. So we're going to move everything over to the left-hand side. 3x squared, because if we take 7x squared minus 4x squared, 3x squared plus 4x minus 1 is equal to 0. Then next thing is put everything to the quadratic. So here's A, B, C. So we put everything into the quadratic. Oh, battery changed. Be right back.